So as I go through these notes, you'll notice that they're already filled out. This is kind of like what you'd call my answer key. Please copy down everything that you see, plus any additional comments that I add to it. Feel free to pause the video if you don't have enough time to get it all copied down. The linear function, before I get started, there are, I believe, 9. 1, 2, maybe I can do this faster. Let's see, 1, 2, 3, 4, 5, 6, 7. No, that didn't count right. Let's see if I can make it bigger over here so I can see the whole thing. I'm trying to count how many parent functions there are. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 parent functions. And we are going to study each one of these parent functions. It's going to take us the whole year. Everything that we do from here on out will be learning about these parent functions and characteristics and how to find all of these things, how to solve them, how to graph them, how to transform them, what word problems look like when we're working with each one of them. So these 9 families are going to be what we study the entire rest of the school year. So please be sure you get these memorized. When I say memorized, what I expect is if I give you the name, you can give me the equation, and then you can draw me what the parent function looks like. Or vice versa. If I give you the graph, you can name it and give me the equation, or if I give you the equation, you can name that equation and show me what the graph looks like. So there's 3 pieces of information, and from those 3 pieces of information, I'm going to provide you with one, and you've got to be able to provide me with the other 2. So get all of that memorized if you possibly can. Then if you have this graph memorized, answering the questions about domain and range. Domain and range doesn't necessarily have to be memorized. You should be able to look at this graph and say, oh, I see that the domain is from negative infinity to positive infinity, because this arrow right here is going to be forever going to the left, and this arrow right here is going to be forever going to the right. So that means the domain is all real numbers. The range is also all real numbers because this arrow is going down forever. So my y values are starting at negative infinity. This arrow is going up forever. So my y values are going to positive infinity. That's why the domain and range is all real numbers. And that's going to be true for any version of a line that we give. This is, again, the parent function. That means that all other functions that are lines started off as a parent function, and then we did something to it. We made it steeper, we shifted it up, we shifted it left, we shifted it right, or we reflected it. We're going to do something to that parent function to create all other linear functions. However, because the domain and range is all real numbers, it doesn't matter what you do to it. The domain and range is going to stay all real numbers. The only thing you can do to this line that would change the domain and range is if you restrict it. And in other words, you say, you know what, I don't want to graph the whole line. I only want to graph part of it, and this is the part that I want to graph. If you restrict the line in any way, then you're going to change both the domain and range. And yes, we will be studying lines with restrictions in just a few weeks. So notice that this domain and range right here is written using the symbols for all real numbers, that double bar R. That is what they write when we're using inequality notation, because we want to include all the numbers. So the inequality notation is written so that I'm having trouble with my tablet. So hold on. Okay, there we go. So this is what it would look like if we're doing inequality notation, because we can't say that it's everything. If we're using interval notation, then it would simply be what we know the intervals to be: negative infinity, and then comma, positive infinity. And the same would be true over here: negative infinity to positive infinity. That is interval notation. These R's right here are what they use for inequality notation, because it is all real numbers. We can see that the x and y intercept is just written down. I don't know what that box is. I just tried to get rid of it. We can see that the x and y intercept is the same. It's 0, 0. That's because this line right here is passing the x-axis at the origin, and it's also passing the y-axis at the origin. So the point 0, 0 is both the x and the y-intercept. 0, 0, the x and the y-intercept. This piece of information is talking about how many times is it possible for your graph to cross the x-axis. Some equations, like you're going to see this one down here, the absolute value equation, can cross the x-axis more than once. A linear equation will not. A linear equation will only cross the x-axis one time. And the place where it crosses the x-axis, that's what we call either a root or a zero. A root or a zero. That's where it crosses the x-axis. Okay, I'm having trouble with my pen. X-axis. Where it crosses. So also known as the x-intercept. So the maximum number of times that this linear equation, oh, I see what that is. Hold on, let me delete it. There we go. So the number of times that a linear equation will cross the x-axis is going to be 1. In behavior, this is new. This is your Algebra 2 stuff. All of this other stuff up here you probably talked about in other courses, but in behavior is new. What I'm talking about in behavior is this right here. This is what I'm talking about. Okay, and this in behavior is basically telling me as these symbols right here are as basic as me saying this graph is this graph that I have right here is going up on the right and it's going down on the left. That's what this notation over here is saying. So basically you have to know that each one of these symbols right here is just one of these words. Okay, so this is saying as our x values approach infinity, that means as our x values get bigger and bigger and bigger and bigger, my y values, because that's what f of x is, are getting bigger and bigger and bigger. So anytime it says x approaches infinity, that's just the symbol for us to say on the right, because x and y is either right or left, and if it's going to positive infinity, we're saying right. If we're going to negative infinity, we're saying on the left. Okay, this is the symbol for saying left. And then these two notations over here, these are the symbols that we use for the words up and down. So if the y values are getting bigger and bigger and bigger, that means that my equation or that my graph is going up. And if my y values are approaching negative infinity right here, then that means they're going down. So as f of x approaches negative infinity, that's the symbol for the words down. Okay, so I won't have to talk this much about each one of these because, Lord, that would be in a crazy long video. I'll go faster from now on because I won't have to explain that this reads as x approaches, that's what that arrow stands for, as x approaches positive infinity. That's just a way of saying on the right, the function, our graph, is going up. As f of x approaches positive infinity, that's up. As x approaches negative infinity is left. As the function approaches negative infinity, that's down.